Chapter 2, Operations and Expressions. We're going to start with section 2.1, Expressions. Example 1, a person is driving 3 miles per hour over the speed limit. For each speed limit shown, find the driving speed. So part A, 55 miles per hour is the speed limit. And they're driving 3 miles per hour over the speed limit, so their speed is going to be 55 plus 3, or 58 miles per hour. In part B, if their speed limit was 70, they're going 3 miles over the speed limit, their speed would be 70 plus 3, or 73 miles per hour. Okay. In each of these two examples, part A and part B, we're able to finish the addition and get a final answer. In part C, since their speed limit is s, a variable, miles per hour, we'll follow the same steps we took in parts A and B, s plus 3, but we cannot combine those, so s plus 3 miles per hour must be our final answer. We call s plus 3 an expression. And an expression is a combination of variables. So s is the variable, constants, like the 3, and operations. And operations are anything that you might find in the list of order of operations, such as plus, minus, multiplication, division, etc. Some examples of expressions are s plus 3, like we saw before, or x squared minus 9, or the square root of x plus 1. Square root is another one of the operations, so are exponents. So you might have something like something squared would be another operation. Alright. Example 1 continues. Substitute 65 for s in the expression s plus 3 and discuss the meaning. So we're going to substitute 65 in for s. So we've got 65 plus 3 is 68. Now discuss the meaning. So what this means altogether is since 65 was the original variable, the original value substituted for s, that was the speed limit. And the driver is going 3 miles over, so their current speed is 68 miles per hour. So we know a couple things from here. We know that the speed limit was 65. And we also know that the current speed, or the driver's speed, is 68 miles per hour. All right. Example 2. A certain type of pen costs $3. Complete the table to describe the cost in dollars of n pens. Alright, so it's $3 for one pen. So if you want 5 pens, you're going to take 3 times 5, or $15. Alright, it's $3 for pens. So you're buying 6 pens, 3 times 6, be a total of $18 for the 6 pens. 3 times 7 will give you $21 for 7 pens, and 3 times 8 would give you $24 for 8 pens. So what we're doing right here is we're practicing describing the cost for a known number of pens, which leads us to describing the cost for an unknown number of pens. It doesn't matter how many pens it is. I'm always going to take 3 times the number of pens to compute the total cost. So 3 times n is going to be the cost for n pens. Alright, so the expression is 3 times n. We want to evaluate that for n equals 10. So 3 times 10 is 30. What does that mean? It means that it costs $30 for 10 pens. We need to state both of those facts in our answer. Don't just state the 30 and say what the 30 means, as in $30. Also state what the 10 means as in 10 pens. Both values with their appropriate units are going to be part of our answer in the explanation bit of this piece. Alright, next page. We blank an expression by substituting a number for each variable in the expression and calculating the result. We evaluate an expression. So in example 3, if a person buys N audio CDs, the cost is $16N. Evaluate 6N for N equals 8. What does the result mean? So 16N, N is going to be 8, will be 16 times 8. 16 times 8 is 128. And what does this mean? So again, I need to explain what both the 8 and the 128 mean. So this means that if a person buys, so the person is going to buy N CDs. So it's going to be N is 8, buys 8 CDs. It costs, the cost is the result of a 16N, so the cost is $128. Example 4. Some students rent an apartment together. Each roommate pays an equal share of $900 in monthly rent. Let N be the number of roommates. Find an expression to describe each roommate's share. Okay, so that's the total rent, $900. We're going to have N roommates. And so we're going to divide this cost up evenly for each of the roommates. So 900 divided by N should equal a roommate's share. Evaluate the expression for N equals 5. 900 divided by 5. 900 divided by 5 is 180. What does the result mean? 5 roommates, N is 5. 5 roommates would pay $180 each. Alright. Definition. Let A and B be numbers, then the blank of A and B is AB. Okay, so this is the definition of a product. Product is another word for multiply. When I multiply A and B, I get AB. We call A and B, the two parts in the product are the factors of AB. So a couple definitions there. The definition of product and factors. And the second bullet, when I have division, I'm going to use the word quotient. The quotient of A and B is A divided by B. So again, quotient is another word for division. The product is another word for multiplication. And the two numbers that are parts of the product are called factors. Alright, in the next objective, we're going to look at translating sentences that are written in English word into mathematical symbols. So we need a couple of common words for each of these mathematical operations. So addition, a couple of the common words, like we might see something like add, we might see something like more than, or increased by. These are a few of the common ones. There are a few more. If you check out this table in the text, it'll give you a few more words for addition. The symbols for addition are the plus symbol. Subtraction, there's a few. You could just say minus. You could say decreased by. You could say less than. Or less. There's a couple of these that we'll want to pay special attention to, especially less than and less are going to have different meanings, but both have the word less in them, so sometimes it can be confusing to tell the difference between those two. When we look at the examples on the next page, we'll get an idea what I'm talking about there. All right. The symbol is just the minus symbol. Multiplication. use a lot of words for multiplication. We could say product. Sometimes people say times. If you're using two fractions, the common word is going to be of for multiplication. Some other words might include something like twice. It's a little bit more specific. It's specifically 2 times. Now, in multiplication, there's a couple of different symbols. Unlike addition and subtraction, where there's pretty much only one, multiplication there could be several. Some of the more common ones are, in arithmetic, you may have used an X. However, we're not going to use that symbol in algebra because it looks like the variable letter X. So instead, if you wanted to use something like that, you could make an asterisk. And actually on the keyboard, the asterisk, Shift 8, is going to be your multiplication key. You could use just a dot, or you could separate numbers by a pair of parentheses. Right? Words for division, we could say divide. We could say quotient. And divide actually is going to be in 2 parts. We could say divided by or divided into. So I'll write those both down. And again, just like with subtraction, less and less than have different meanings. Divided by, divided into have different meanings. Division also has a few symbols. We can use the bar with 2 dots. We can use a fraction bar. Now, keep in mind that the subtraction symbol and this bar are not the same. This would be more like 2/3, wherein this would be more like 5 minus 3. Okay. We could use a slash division sign. That's the division sign you'll find on a keyboard. And you could also use a long division symbol, less frequently used in any algebra or algebraic problems, but you'll see that used in arithmetic problems. On the next page are some examples. So in these examples we have several problems that are written in words and we need to translate them into English, and vice versa. A couple that are written in symbols, we need to translate them. Sorry, the ones written in words we need to translate into symbols, the ones written in symbols need to be translated into words. So 6 less than the product of a number and 3. Alright, so less than can be some tricky, so we really need to listen to how this sounds. Right? 6 less than a product of a number and 3. I'm going to pause on less than, and I know what the word product means. That's a multiplication. The product of a number and 3, this part right here, the product of a number and 3 is going to be, say, 3 times x. Okay. Now it needs to be 6 less than that. 6 less than, the way that phrases in English, what that means in English, is I need to take 6 away from the result of this product. So it'll be 3x minus 6. Less than is an indication that that subtraction will be the latter operation. The subtraction is going to happen after whatever was after the word less than. Okay? A number subtracted from 8. Just like less than, subtracted from also is going to imply that the second part of the operation comes first. The number is subtracted from, taken away from the 8. So I'm going to start with the 8, then minus the x. Alright. In contrast, part C, these are all subtractions, right? Less than, subtracted from, and difference. Difference does not imply an order switch. The difference of a number and 9 is a number minus 9. So subtraction can be particularly tricky to know that the 6 comes on the end. 6 less than, 6 taken away from the number. A number subtracted from 8, that goes to the end, but this one is just lined up as it is, the difference of a number and 9. Okay? So pay special attention when you have any of those subtraction words to make sure that you get the order correct. The product of a number and 5, or the product of 5 and a number. Alright. So it says the product, multiplication, 5 in a number. Again, I don't have to put a symbol between the two of them if I have a number and a variable. It's okay to do so. You could write 5 times x and be equally correct, but we're going to get in the habit of, when we have a number and a variable, of putting no symbol between the two. If it's two numbers, you do need a symbol, but with a number and a variable, it's understood doing multiplication if there's no symbol between them. Alright, so let's translate some of these expressions into words, then we'll go back and translate some more from words to symbols. 7 minus x. I could just write those words, 7 minus x, but let's try to use one of the subtracted from or less than for some extra practice there. This could be 7 less than a number. 7 less than a number. You can see how that matches up with part A. And part F, it's a division, so one of the division words I could use is quotient. So I'll say the quotient of the two things we're taking the division of, so the quotient of a number. We always use the phrase a number to signify the variable, and 4. Alright. Part G, the sum of 6 times a number and 13, comma, added to 3 times the number. When you have a comma, it's a stop in the expression here, so we're going to read everything up until the comma, then we'll finish what's after the comma. The sum of 6 times a number and 13. So sum is addition, and it's the addition of the quantity 6 times a number and 13. So 6 times a number is 6x. We're adding that, summing that with 13 plus 13. That all comes before the comma. So let's find out what comes after the comma. So we have this quantity added to 3 times the number. All right. So I have the entire quantity that we began with, 6x plus 13, added to 3 times the number. 3 times the number would be 3x. Now, since I have to do this all first, I can put it in parentheses, but I know from order of operations that the first addition will come first anyway, so it's okay not to have this in parentheses because the natural order of operations will cause this to happen first. Alright, let's look at part H. One more time, we've got a comma, so we will read what's in front of the comma, then we'll read what's after the comma. 12 times the difference between 6 and twice a number. Okay, so there's a multiplication right here, 12 times. So it's 12 times the difference. So that tells me that what I'm multiplying 12 by is a difference, is a subtraction. So it's going to be 12. Let me write this underneath and sit over here in the line for a moment. It's going to be 12 times some quantity, and that quantity is the difference, the subtraction between 6 and twice a number. So I definitely need parentheses here. 12 times, not 6, not twice a number, but 12 times the entire difference. That's my clue to put parentheses here. Alright, that's before the comma. All of the stuff before the comma is subtracted away from 14. Remember that subtracted from is going to throw all of this to the end, take it away from the 14. So our final expression will look like this. 14 minus 12 times the difference of 6 and twice a number. Okay. Commas can be tricky, especially when, what do I do when there is comma versus when there is no comma? Okay, so let's look at some of these right here. Some of these English ones are amusing. Woman without her man is nothing. or women without her, man is nothing. Okay, so there's a difference in those, so we read those with where the comma placement is, where you put the pause. Do not break your bread or roll in your soup. Okay, so don't break either bread or roll in your soup. Cool. Do not break your bread or roll in your soup. Don't break your bread and don't roll in your soup. So those are two different statements, the only difference being a comma. The same thing happens if we're reading something in algebra. The product of 6 and a number increased by 5 is 30. The product of 6 and a number increased by 5. Okay, when I see this without a comma, the two parts of my product are 6 and a number increased by 5, and being the divider between the two parts of the product. So this is going to, without a parentheses there, without a comma there, it's going to imply parentheses. When there is a comma, it'll be the product of 6 and a number, then increased by 5. Okay, so whether or not there is a comma makes a big difference in some of these sentences. So here are two identical sentences, one with a comma, one without a comma, and we'll get these properly translated. The product of a number and 13, stop. So the product of a number and 13 would be 13 times x added to 3 times the number. Okay? The product of a number and 13 added to 3 times the number. That's the product of a number and 13 added to 3 times the number. Big difference in the two expressions right here, again based on whether or not there was a comma. So just something to think about when you are reading an expression, translating it from English, is to pay attention to those markers. You might want to go back to this page as a reference.